Hey there, Nick Hackers here. In this video, we're going to go over how to build Docker images that support multiple CPU architectures using Buildx. This will allow you to run one unified command with your normal Docker file that you probably have, and it's going to be compatible with both AMD64 as well as ARM64 CPU architectures. There's other platforms to support as well. So throughout this video, we're going to go over, the use cases of when you might want to use Buildx, how it works a little bit, and then we're also going to jump into the terminal, run some commands on how to create a Buildx builder, as well as building images that support multiple CPU platforms, as well as pushing it up to the Docker Hub so that you can see your multi-architecture image there up and available. Now, if you're not using the Docker Hub, that's fine. You can always use a different Docker registry if you'd like, but I do prefer using the Docker Hub, and you can always feel free to watch the video as well. So right now, this blog post is on localhost. By the time you watch it, I'll leave a link in the description so you can check it out. We are going to go over some points here in this blog post, but really we're going to be jumping into the terminal, running a lot of commands here. I just want to make sure that I don't miss any steps here, as well as open up some links here that will be interesting. I'll link all of those in the references as well. So yeah, Buildx, super handy if you want to support multiple CPU architectures here. And the main use case here is you might have a single Docker file that you've probably built and used over the years, right, for multiple different projects. Again, we're not going to have to do anything different to our Docker file to make this work, which is really nice here. But yeah, let's say though that you want to be able to build your Docker image and have it support more than one different CPU architecture. So for example, you might have something like a 64-bit Intel or AMD-based CPU. Those are both typically classified as AMD64 CPUs. Alternatively though, you might have something like Apple Silicon, right? You might have an M1 or an M2 or an M3 or, whatever Apple decides to make in the future. You could also have something like a Raspberry Pi, or maybe you're on a cloud provider that supports ARM-based CPUs. For example, what is that one from AWS, like Graviton or something like that? Hetzner and some others, they also have ARM-based CPUs here. These are all classified as ARM64, although technically there's a few variants and versions of ARM. We don't need to get too deep in the woods there, but yeah, that is something to be aware of. And we can also build for those specific versions and variants if you want, using Buildx as well here. So yeah, there's different pros and cons, right, of different CPU architectures. That goes way beyond the scope of this post. You can research that stuff if you'd like, if you're interested here. But in any case, Buildx lets us build Docker images that support multiple platforms. And yeah, the best part about it, we don't need to modify our Docker file at all. We don't need to run any crazy things other than just running a couple of Buildx commands to get started there, and we're going to be all set here. So yeah, if you've never heard of Buildx before, but you have an existing Docker file, good news, it's going to work without issues, almost certainly, but no guarantees, but it should. So yeah, what the heck is Buildx? So Buildx is actually just a plugin that's installed by default with Docker Desktop, when you go and install Docker, but it's also installed by default on native Linux without Docker Desktop if you happen to use this one little get Docker script here. So if we do a search here for Buildx, it just gets installed as a plugin. If you're using some package manager, for example, apt with a Debian-based system, you can just apt get install here Docker Buildx-plugin. But again, if you're using this shortcut installation script here, then that's going to be installed for you by default. But if you're not, maybe you're installing on a different system manually or whatever, yeah, you can just install this package, and you can find it in your distro's package manager, as long as you pull in the repo list from Docker there. So yeah, it gets exposed to you as a Docker Buildx command in a very, very similar way to how Docker Compose is available to you on the command line. These are both Docker plugins. For example, you can do a Docker Compose -s help here. This is Docker Compose v2. It's the Go binary version of Docker Compose that's built as a Docker plugin. Well, we can also do Docker Buildx here, and we can also do a help and get similar information. Of course, there's different commands here because it does something different than Compose. But yeah, operationally or technically, they're just two Docker plugins that work independently. So yeah, you can run something like a Docker Buildx ls to see which driver is currently in use. Chances are you have at least a default driver with a status of running. So let's go and check that out here. So if we just run Buildx ls here, we can see that in my case here, I do have the default one. I didn't do anything special or extra to make all of this work here. This just came by default when I installed Docker within WSL2. Chances are something is very similar to your setup as well, unless you've created custom builders, in which case you'll see more that's listed there. Spoiler alert, we're going to see that pretty soon here. But yeah, that's it. It's just something available, and it's currently in use here. And yeah, here's a fun fact. You've probably been using Buildx all the time here in the past without even knowing it potentially. So when you run just a regular Docker build command, or, let's say you're using Docker Compose and you do a Docker Compose build, it's actually really using Buildx under the hood. This became the default on Linux back in February 2023, back with Docker Engine version 23. But Buildx has been around for quite some years ahead of that, or before that, right? So, I did some researching and poking around. It looks like it was first introduced in about July 2019. I vaguely remember it being announced at a DockerCon. I'm sure there's some Docker blog post about that one there. But yeah, this is now approaching, almost 5 years. I'm recording this in early 2024. But yeah, you may have remembered some years ago where when you started running a Docker build or Docker Compose build, the output when you built the image looked a little bit different. It used to all be in like white text and showed information like sequentially. But then Buildx came along, and then it's like you start getting those like little blue highlights in the output. Certain things can be done in parallel. And we're actually going to see an example of building that soon. So if you're not sure or don't remember that, or maybe you haven't been using Docker that long, yeah, eventually, in between 2019 and today, you may have seen those differences depending on when and how you use Docker. But yeah, although, at least at the time of making this post here, that default builder that we just took a look at here, when we ran an ls here, it actually doesn't support building multi-platform images. So we need to create a new Buildx builder. These are basically kind of called contexts here, and we're going to get to that in a second here. But yeah, I just want to let you know, like, we can't just use this default one here to build multi-platform images, at least not right now. I don't know if Docker's going to change that or do something different. Who knows, right? That's in the future, and I know I can't predict all of that. So let's go over creating a new builder here just to see how it works. There's not going to be any like massive system load to create this, right? It's also something that we can delete later. We can RM it if you don't want to keep it around, but you may actually end up keeping it around just to build your own multi-architecture images in the future, after you watch this video potentially. So yeah, let's hop into the terminal here. And again, you can watch along. You can copy paste from the blog post if you'd like here, but I'm going to go and create this. It should be created basically instant, right? Within 1 second or so. But yeah, let's go over some of the flags here just to see what's happening. So we have Docker Buildx create, right? This is the subcommand of Buildx. You're basically just running a command that's available to Buildx. We saw that when we ran the help menu there. Let's ignore this driver option just for a second here. The use flag is going to have us use this new context that we just created as of right now. We can see this in a second. Actually, let me just rerun this ls command here. And we can actually see up here, when there was only one builder available, you have this little asterisk next to the default one. Now we have that next to the multi-arch one or architecture there. That's because of the -- use. This is kind of like comboing on creating it and then using it. So it's like we're activating this one. So when we build Docker images now, we're going to be using this new context here for multi-architecture. And the name, by the way, I just happen to name it multi-arch because it kind of makes sense because, you're just using this to build multi-architecture images here. You could technically name this with whatever you want, as long as it adheres to Docker's policies on naming things. There's maybe some certain characters that you probably can't use. If you omit the name completely, then you'll just get a random name that Docker generates for you. That's always fun to look at here. But yeah, let's go back to this driver option network equals host flag. This may or may not be something that you'll need to set. I noticed with WSL2, which is where I have Docker installed, technically right now not without Docker Desktop, but I am thinking back of going back to Docker Desktop. The only reason I switched to running it directly in WSL2 is because some version of Docker Desktop kept hitching on my machine, like it kept making my whole machine hitch for a second or two all the time. I don't know if that was a bug with Docker Desktop. I know my machine's like 9 years old, so maybe there was some problem with that. But in any case, if you are running WSL2 with or without Docker Desktop, there may be a chance when you go and try to build your Docker images, there's not going to be any network available. There may be some conflict with like WSL2's networking and Docker in that case, but I found setting this to use the host network solved that problem completely, and I'm able to pull things from the network when building images, etc., using Buildx here. So if you get that issue where you get some like network related error where maybe you can't connect to something that that should be able to connect because your internet is working, then you can try adding this flag. But I would try not adding this first because you may actually not need it. But yeah, once you have all that set up there, then we end up with having a new context here, and it's activated here. And yeah, cool. So let's go back to the post here to get a little more reference here. Yeah, that's basically all that here. But yeah, we can see something very similar we just took a look at here. But let's go and inspect these builders. Let's actually see what's a little bit different between that default one as well as the one that we just created here, because there is a way for us to uncover why the default builder doesn't support multi-architectures by default, whereas the one that we just created does here. And by the way, I kind of just wrote this here, like we are operating in early 2024 based on running Docker Engine 25. That's what I happen to be running here. If I do a Docker version here, it is version, 25 something, right? So these things may change very slightly depending on when you're watching the video, or, of course, it's not going to show February 10th here when I'm recording the video here, but you get the idea. So let's actually run these commands here and just take a look at both of the outputs. I'm actually going to split this so we can look at both of them at once. I might as well, it doesn't matter. Well, I don't know. I'll just go here just so the terminal lines up. But yeah, let's do Docker Buildx here, if I can spell, and then we're going to do an inspect on the default one. That's going to be up top. And then we'll do the same thing over here where we do a docker buildx inspect, except in this case, we're going to go with the multi-architecture here just so we can take a look at both. So cool, it all fits on one screen, which is a nice coincidence here. But we can see here there are quite a few differences in the output. So right now there is no platforms property associated with this one because we haven't built any images there. That's not a big deal. This is probably always going to line up with whatever CPU architecture your system has. For example, I'm running an Intel 64-bit CPU here. We can see Linux AMD64 here. There's also some variants and versions specific to that as well as 32-bit versions too. But if you're running something like Apple Silicon, maybe you have an M2 or M3 or M1 or whatever, you may see some different outputs here. That's not super duper important for right now. The really important property, the difference here is this driver. So the default driver is using Docker, whereas the multi-arch one is using Docker container. And when we use Docker container, I think there's another one too, like Docker Kubernetes or whatever. This is what's giving us the ability to use or building images that support multiple platforms here. So the default one is just going to build images for whatever your system's architecture is, either AMD64 or ARM64. But yeah, let's go back to here because there's some interesting links to look at. So yeah, so there's QEMU emulation here. I don't know. People different, they pronounce this one in 11 different ways, but that's not too important here. But this is a very super solid open source emulator. So it actually emulates different processor types. So this is the ability for like my 64-bit Intel CPU to be able to create a compatible ARM64 binary or, some image that's compatible with both here. It's also something that you may end up using with KVM. If you've ever worked at virtual machines, maybe this term is familiar to you. So yeah, you can always check out the wiki if you want more details here, but Buildx is going to be using this to allow us to build multi-platform support for different images there. So that's really nice. Again, this is something that's like a little bit lower level. Typically, you don't need to think at this level here, but it is nice to know just how things work a little bit at a high level in case you need to debug something there. So yeah, let's take action here on this new Buildx context we created here and actually start building and inspecting some images that we built with Buildx here. So in this case, if you already have a Docker project set up, you can go and build your Docker project using Buildx, with this context that we just created here by running a command very similar to this. Of course, you can change the tag to be whatever you want here, but there's a couple of things that we'll want to go over here in a second here. Well, I'm going to, run this in a terminal in a minute here, but if you need some examples just to run because maybe you don't have something, but you do want to run it locally, I've got all sorts of different example Dockerized web applications here for like Rails and Django and Flask and Node, as well as Phoenix as well. Yeah, so I'll leave a link to this search repository here if you want some projects. There's also this little web server project I made here. It's like a zero dependency Python Echo server that happens to be wrapped up in Docker. So this one may build a lot quicker than one of these because these are like full-fledged starter applications, like a Rails app that's going to have a web server and Sidekick for background work and Postgres, Like this one is just building something pretty quickly. And that's actually what we're going to be building here. That's why in my terminal, I was checked out to this directory here. But that's not super important until we start building things. But yeah, I'm actually going to copy paste this one and just run it straight up, and then we'll go over some of the flags here and what we're looking at. So I am in that web server directory. For example, if you were to git clone this directory locally, then yeah, you can run this command here. And let's let it rip here, and then we'll just evaluate this command after the thing has been built. This should build pretty quickly because it's like a 40 meg image that basically just uses the base Python Slim image with 50 lines of code of Python. So all that's getting set up now. This is normal output you've probably seen. Remember I was talking about before, seeing that build output and things maybe happening in parallel. This is Buildx running, and again, even without having to create that custom build or remade, you probably have seen similar output in your own Docker images here. So yeah, we can ignore this warning on the very bottom that just basically says that this build results are only going to remain in the build cache here. We need to either push it up or load it into an image that Docker can use. Ignore that for now, not super important. But let's go back up here to this command that we ran. So previously we ran docker buildx create. That's creating the build context itself. But then we actually need to build a Docker image, right? So that's what the build command is going to be doing. In this case, I'm just tagging it to be testing 1, 2, 3. We're going to go into more practical examples. Like let's say if you were to push this to the Docker Hub, stuff like that. The dot here at the very end is going to be the current directory. So in this case, it's the web server. Inside of this directory here, I should mention that there is a Docker file. We'll take a look at it for a second. The contents of that's not important because, this will theoretically work the same with your Docker file or any other Docker file that's been made in the history of the universe, most likely. But the really important one, very important one here is the platform flag. And this is where we're saying hey, okay, these are the platforms we want this image to support. We want to support Linux AMD64 as well as Linux ARM64. And don't be too afraid here, if you're using something like macOS on an M2, remember, you are running your Docker images inside of Docker Desktop. So, chances are, unless you went well out of your way, you are running a Linux file system and all that inside of your Docker file, right? That's what you're setting all up. So this Linux ARM64 is going to work when you run your M2 or whatever Apple Silicon you might have here. You don't need to put like Darwin or macOS or something like that. Likewise with Windows, yeah, you can be Windows and Docker Desktop. Like you're still targeting Linux AMD64 or ARM64, depending on what CPU type you have here. But yeah, that's basically that. And then, just to show you here, I do have a little Docker file here. Not really important to go over what it is. I just want to show you on video that it's nothing crazy. It's just using the Python Slim bookworm, whatever. Running a container as a non-root user. That's almost all of the boilerplate that we see here. It just runs a little web server that will echo whatever headers and payloads that you send to it. Really good for testing webhooks, but that's not the focus of this video. I actually do have a video on this one specifically, so I'll link to that in a card if you do want to check that one out here. But yeah, one thing to make note of here, though, is that after you run this command here, if you were to run a Docker image ls, you probably would have expected testing123 to be in the list there, but it's actually not there, because remember, if we looked at that, let me rebuild this thing so we can just see the output real quick here. There's that little warning on the bottom here that said, yeah, this is only in the build cache here. It's not really produced into an air quotes real Docker image there. We would need to push that basically up to the Docker Hub for that to happen, or we can load it in other ways. Not too important right now, because this is all going to boil down to like probably going to be running these commands in a CI platform, probably not on your dev box, but in any case, we'll get there when we get there. And by the way, that setting that up in a CI pipeline is actually going to be the focus of next week's video. But yeah, we'll get there eventually. Yeah, we need to actually push this up to the Docker Hub if you want to see it as a real image here. But, we'll inspect an already built image from something I've pushed to my Docker Hub in a second here. But I really just wanted to cover this build step here because, yeah, when you're doing this stuff on your own, like this platform tag property is super important here. So yeah, this build command is where we define different CPU architectures you want to support through the platform flag, blah, blah, blah. Right now we just have AMD64 and ARM64 for both Linux there, but we could make that more specific, and we could also choose different platforms if you'd like here. And, I just wanted to mention here with macOS, yep, you're still running Linux and Docker Desktop here. But yeah, those two platform definitions that we just took a look at here a second ago, this will support most modern desktop CPUs as well as newer Raspberry Pis, AWS's Graviton CPUs, and all sorts of different other ones. So yeah, and also it's worth noting here that Linux AMD64 gets normalized to, I think I should have put ARM64 here. It gets normalized to, yeah, ARM64 V8. That's a typo in the blog post. I'll fix this by the time it's posted here. But yeah, V8 of ARM64 is a very widely used ARM version nowadays. So you could explicitly put the version number if you'd like version 7 and version 5, and we're going to get there in a second here. But yeah, I found just putting these two here has been very good in terms of compatibility. I haven't done anything different here. But again, this is your choice to choose whatever platforms you'd like, right? If you want to add more, it's just a comma separated list here. You can see there's a comma in between both of these entries here. I don't think there's a maximum to how many you can add. Maybe there is like an upper bound somewhere, but as we're going to see soon, there are certain places or different official Docker images that support like 8, 9, 10 different platforms here. But yeah, that's up to you. So what I would actually suggest too, because getting the exact names of these could be a little bit tricky, so you can't just guess them and be like, oh yeah, version 6 is going to be in there, right? So I do suggest going to a really popular official Docker image. I'm a big fan of using Debian even as a base image here, but if we take a look at their tags, and we're going to look at it on their site in a second here, they have all these different architectures here. So this is like 32-bit, it's not really AMD64, but it's 32-bit CPUs here. AMD64, various versions of ARM. We can see there's the V8 one as well. And then there's all sorts of other ones here as well. I actually don't know what these are offhand, but they're supported CPU architectures. Maybe there's certain systems, maybe, I don't know, some like older Raspberry Pis or whatever, some other hardware that you may want to support as well here. But yeah, this really comes down to whatever platforms you want to support here. Again, I've never had issues with that one. So let's go and take a look at this one really quick here, just so we can actually visually see this, because it's kind of nice. So if you just go to the Docker Hub here, this is Debian. You're probably going to be hit on the overview tab by default here, but if you just go to tags, depending on if Docker doesn't change their layout here, and we go to that little more link here, we can see all the different architectures that are available for, unstable Slim. Again, this is like a rolling thing, so like unstable is going to change in a year or two to be some other distro, so maybe there's going to be more listed here or less listed here, but yeah, they're all listed here and you can go and check them out. Cool. So let's go back to this post here. And, again, like you don't need to go to the Docker Hub to get this information. So Docker Buildx, let's go to the terminal here and run some commands. I'll break it down in a second here after it runs. But yeah, over down here, we can see we are using this one sub command called image tools, where you can run and inspect on a specific Docker image, Debian in this case, and unstable slim is the tag that we were just looking at before. But in this case, we could see all sorts of different manifests that were created for different platforms. Here we have AMD64, ARM5, 8, blah, blah, blah. All the other ones that I'm not really sure off the top of my head what they are, but they are listed here. So the list that you see here will match the list that you see over here, as long as you're using the same tag, which is nice because sometimes you're on the command line, you just want to see what architectures are supported. So you have that option there to use if you'd like. Now, though, let's say that you've built your multi-architecture image, or you've pulled down some image on the internet, and let's see if it's actually compatible with your system's architecture type. So in this case, remember, I mentioned having that little web server Docker image set up here. So you can run this locally on your box right now if you'd like. So let's do that. Well, I will. You feel free to just sit back and watch. But you can see in this case, the architecture is AMD64. Again, that's because I have a 64-bit Intel CPU running on my machine. If you were to be running this on some Apple Silicon, then you would actually see ARM64 here as the architecture because, this Docker inspect, I'm just grepping for architecture. I know there's like Go templating language that you can use to parse this out because it is a JSON response by default. It's in here somewhere over here, but I always forget those Go templating syntax or whatever. So for me, it's a little bit easier to grep out. But yeah, if you ever wanted to see the architecture of an image, you can go and find it when you inspect an image there. So that's always nice. Let's go back to the post here and yeah, now let's go a little bit. Oh, and yeah, this is just a quick way to determine, right? If it supports your host's architecture. I will mention this though. I do know a little bit about Apple Silicon. I don't really work too much with their devices, but I have a work laptop that I use once in a while that is that. And I'm pretty sure it's compatible with being able to run AMD64 through using some emulation on their own. So yeah, just because you don't have an ARM64 architecture supported on an image, if you're running some Docker image on an M2 or something like that, you can still probably run AMD64. There may be some performance implications of that. But yeah, I just wanted to point that one out there. But yeah, now let's go over pushing images to the Docker Hub. I'm actually not going to run this command specifically because I don't want to repush the same tag that I have, just to update the timestamp or whatever. But it is basically the exact same build command we ran before. The only change there is I added the -- push flag. That's it. Of course, I changed the tag to match things that would need to match for Docker Hub. But yeah, again, like this is assuming you have a Docker Hub account. You're logged into it on the command line using Docker login. If you actually wanted to run this command here and push up your image to the Docker Hub to go and check out, something like this, where you can see different things. Because again, if I go to maybe the web server one here, if I do a search for web server, I don't know if that's going to come up. It would be interesting if it does, because it's a pretty new repo here, like from the other day. So I'm pretty sure I'm not going to be like at the top of the search results. So let me pop in NickJJ maybe, because that's my Docker Hub username. Yeah, there we go. Cool. So like if I went to the tags over here, then we can actually see that it does support AMD64 and ARM64 for both latest and version 0.3.4. So yeah, going back to the blog post here, I'm pretty sure I linked to that anyways there. But if you would actually do this on your own, and let's say that you wanted to push your image up, then you would just change this hello to be your Docker Hub username. In my case, it's NickJJ. Then the testing 1, 2, 3 would be web server in this case. Really depends on whatever image name that you want to use. And then optionally, you can put in whatever desired tag that you have, like V1 or 2 or, whatever options you may want to do there. You can also emit that, and then it's going to be the latest tag. So, I would actually suggest building 2 of these images, one for whatever tagged version that you want, and then also doing again for latest, just to be explicit. So you have both of them up there. And that's how we wound up here, where I had the latest one as well as this version as well. So yeah, that's going to do it for getting things up to the point where yeah, we kind of know a little bit about Buildx. We've made a custom builder. We've built some images. We push them up to the Docker Hub potentially if you followed along that far or want to do that. So like, what's next? I mean, one, you can go and remove that multi-architecture builder context that we created before. You can just run this command and it's going to disappear. And now if we do a Docker Buildx ls here, we can see that it's been removed. Everything is good to go. You can always run something like a Docker system prune to get rid of your build cache and stuff like that. Depending on the size of your image, there could be some hundreds of megabytes or smaller. In this case, this project is small, so there's not that much there, but it is lingering around somewhere. You may want to clean that one up. Again, super handy for building multiple CPU architectures for different platforms here on your local machine here. But you probably, when you're really going to be building this locally, I mean, there could be a case where maybe you don't have a Docker registry account like the Docker Hub. Maybe you're not using a CI pipeline system like GitHub Actions or Bitbucket pipelines or whatever, GitLab runners or something like that. And then maybe you'd want to build multi-architecture because maybe you have something like an M2, but you're pushing and building Docker images that are going to run in DigitalOcean on like an AMD64, something like that. But typically, at least I found, like 95% of the time, I am going to be doing this type of workflow here, right? Where you push some code up to GitHub, or feel free to replace this with your Git provider, whatever your preference is here. But you would have some form of a CI pipeline running that's going to, build your Docker image, run your test suite, and if all those tests pass, then it would go ahead and push that image up to the Docker registry, such as the Docker Hub here. And then after that, it really depends on how you're deploying your application, right? But at this point, those images exist in your Docker registry that can be pulled down from wherever your servers are running, and then you can restart those containers, maybe run some database migration, basically, all things that you would do during application deployment here. But wouldn't it be nice if we can just have all of that happen in a CI pipeline where it is actually going to be building and pushing multiple CPU architecture Docker images to the Docker Hub, every single time that we pushed up a brand new Git tag. So you can imagine, like, if you commit to the master branch or merge something in master or main, whatever, you wouldn't necessarily want that to cut a release out to whatever, your library or package does here, whatever you're, building with Docker. So there are ways with GitHub Actions and other CI platforms to basically say, like, yeah, only when a new Git tag is pushed, then we do the action that we want to do. In this case, build the image and push it up to the Docker Hub here. So yeah, that's going to be next week's video. I normally don't do series where like things are interlinked between multiple weeks or whatever, but this was kind of covering a lot just to get the basics of Buildx here. And yeah, then next time we can focus specifically on GitHub Actions. And if you're using Bitbucket pipelines or GitLab pipelines, whatever they're called there, then it's not going to really be any different. It's going to be the same things. So you're just going to be replacing the syntax for GitHub Actions to Bitbucket pipeline. Now, there are actions which are a little bit different than writing like the raw shell scripts, but we'll cover all that stuff in the next video. But with that said, yeah, if you have any questions, let me know in the comments below. I'll do my best to answer all of them. With that said, if you liked the video, please give it a thumbs up because it really does help a lot. Thanks a lot for watching, and I'll see you in the next video.